Hello OSA, Taras here. For the last couple weeks, I've had the pleasure of bringing to you a small little fraction of the diversity of all the different fish that are offered in the average aquarium store, and then even some of the more rare ones that are only offered in nice shops like here at OSA. Today, we're beginning a bold new series, going into what is relatively unexplored territory, not only for me and the aquarium industry as a whole, but science in general. Today, we're going to be starting a bold new series called What is a Coral? I'm very excited to have one of my dear friends, Eli here, who knows a lot more about this stuff, to be a co-host with me on this series. And after a couple episodes, I think you'll probably be hearing a lot more from Eli than me. But let's get started. What is that question? What is a coral? People love us because we are one of the most prolific coral stores in the region. If you don't know this, we actually have a coral farm where we reproduce our own sustainably aquacultured corals for sell here at the store. But what is a coral? A lot of people come into the store, even if you've seen, some Blue Planet or something like that, you might have seen David Attenborough's shtick on the matter, but you walk in, it looks like a candy store, right? But it looks like a candy store full of rocks or a candy store full of plants. And even though you walk through and you see all these great shapes and sizes and you're like, oh, I can't wait to have an aquarium of this, it can be very difficult right off the bat for the average novice aquarist to pick up on corals. Corals were one of the things that really revolutionized the aquarium industry. It was fish for the longest time, and it was only really until the 50s and 60s that people started to really fool around with corals. And there were a lot of innate challenges. The lights that work on freshwater plants and land plants don't work on corals, at least not many of them. They're too white and have too much red spectrum, so they grow lots of algae and they do all these other weird things. Coral chemistry, a lot of things like trace elements, alkalinity, magnesium, all these things need to be accounted for in the coral tank, which you might not necessarily need to care about in most fish-only systems or even in some planted aquariums as well. So you walk in and it can be so daunting to see all these colors, and you want to have them in your home, and you want to see them growing, and you want to have a tank that looks as dynamite as some of the display tanks that Ernie set up. So how do you get there? Well, you get there by asking yourself the question we all ask ourselves once we get the coral bug. What is a coral? What the heck is a coral? It's a more difficult question than even what is a fish. Coral is a different class of organisms. It's in the phylum Cnidaria, so it's in with anemones and other things of that matter, called the Anthozoa. And it's defined by their adult form being these polyps, either by using just pure flesh architecture or by using biomineralization to form calcified structures and shapes. These polyps live inside homes. And what gets even more trippy is that with a fish, at least you have just genus and species, and maybe you have some bacteria that make up the fish that help out. But with corals, it can be a lot more difficult. The coral itself, the genus and species, is just that cnidarium. However, that organism very rarely can survive in isolation, and very rarely does it have any color, if any, if it's just in isolation. When you look down and you're seeing all of that light reacting, all of the different colors coming off that blue light, it's because that coral has established architecture, and in that architecture there are cities of bacteria, algae, specifically the dinoflagellates, zooxanthellae, specifically the symbiodinium. There are even saltwater fungi we're finding out. All these diverse creatures that are forming in this hugely complex and confounding biological mosaic. And it's the reflection of all those different critters inside the coral and coming into all of its different crevices and beaming off that into your eye that produces these novel colors, lights, and textures. Very briefly, we'll talk about the life cycle of the coral. So there's basically two major ways that the coral reproduces. It is a colonial organism. So every individual mouth or little feeding apparatus that you see on the coral, that is a different individual. And they grow in a colony structure, and if a certain amount of individuals are severed, they can start a new colony competently. So we call this fragging in the hobby, and it's the most popular way that aquarists that have been successful with particular corals have been able to reproduce and spread particular strains of corals. And over at our farm, that's where Chris Kaz, Bandsaw Bandit, is able to carve up all these different frags and be able to reproduce corals asexually. Now there's another way that corals reproduce, and in the wild, usually with the tides and the full moon, it triggers this great cycle where the coral reef is stimulated to release sperm and egg, and sometimes they can do this asexually. We won't necessarily talk about that, but then the sperm and egg will hit together and you'll get a planula larvae. The planula larvae is just that cnidaria, and then at some point it's going to settle down on some substrate at some point, and at some point it's going to recruit the symbiodinium, the bacteria, the marine fungi, and even the marine archaea that is going to eventually allow it to develop its unique coral shape and architecture in a particular area with the light and water chemistry of which it's grown. That's enough of my spattering about this. I would like to segue now to Eli LaChapelle, and he's going to actually show you a fraction of the diversity that we have at the shop, let alone the diversity of corals that exist out in the wild.
Hello everybody, Eli here. I wanted to thank Taras for our lovely introduction into the world of corals, and I hope that everybody is excited to hear about our new segment, What is a Coral?, and learn about some of the creatures that we have here to offer. I myself wanted to touch a little bit on some of the more basics, just to introduce some of the new hobbyists more so into the hobby, into some of the more practical designations that we make for corals, and to kind of introduce a few of the archetypes that we have for these designations. So today I wanted to talk a little bit about what makes a coral a soft coral versus a stony coral, and then to talk about both small polyp stony coral and large polyp stony corals, SPS and LPS, which are some of the most common designations that we use in the hobby when trying to differentiate corals based on loosely their structure and kind of how to take care of them in the hobby setting, as a lot of the care can be very similar between these designations. So I've brought out 3 of our most popular types of corals here. A lot of these actually come from our farm down the road that would kind of fit into these 3 different designations, one being green star polyps, which are the Pachyclavularia genus. We also have a hammer coral here, which is a Euphilia coral. And for SPS, I brought out a piece of purple Stylophora, which is a small polyp stony branching coral. One of the easier ones for the beginner hobbyists that like to get into some of the more difficult corals, but we'll start with the soft corals. So what makes a soft coral a soft coral? As the name implies, these animals are soft. Their body tissues are soft, and they don't produce a stony skeleton, with the exception of a few kind of obscure pieces of soft coral. But most of these are soft to the touch. They don't produce a skeleton, so they're not as demanding in terms of calcium, alkalinity, and the like when they get into the aquarium setting. These are generally some of the species that we like to get into for beginners when you're just starting out a tank. They don't need the most attention. They don't need the cleanest water, and they honestly offer a lot of different flowiness, some nice patterns, and some easy, rewarding growth for the beginning hobbyists and the experts alike. So this is green star polyps here. This is one of the classic archetypes of the soft polyp coral family. We'll have Danny introduce some close-up pictures, but this is a type of octocoral. So that's kind of what unites all of the soft corals, is that they're classified as octocoralia, which means they have an 8-fold symmetry to their polyps. So as Taras kind of mentioned earlier, each polyp itself is its own organism, its own coral. Each polyp will be arranged in segments of 8. So if you get a close-up of the head, it would look like it had 8 tentacles in the case of the green star polyps. This is a drastic difference in comparison to when we get into the stony corals, both LPS and SPS alike. These polyps are arranged in segments of 6, sometimes 3, especially when we look at the small polyp stony corals. A lot of them only have 6 tentacles per polyp, and this is kind of a true characteristic that differentiates them from the true soft corals. To talk a bit about the LPS corals, like this hammer coral here, they're generally one of the easier stony corals to begin with for a lot of beginner hobbyists. They're nice because they offer a lot of flow and some nice textures to your tank. As you see, this is a type of branching coral, branching Euphilia. It'll grow a bunch of these small little polyp heads here, and they fill in a lot of nice space and offer some nice movement in a tank, which is kind of a drastic difference between that and some of the small polyp stony corals that seem a little bit more rigid and firm in their appearance. Generally, these don't need as much attention as the soft polyp stonies, but a little more than the soft corals, whereas they need attention in terms of higher light demands, feeding requirements, and they also generally need additions of calcium and alkalinity to the water in order to make their stony base. As we start getting into the little more experienced coral keepers, SPS is generally the next designation we get into. So the small polyp stony corals, again, they have this six-fold symmetry to the polyps. They tend to be the most difficult in terms of keeping in aquariums just because they have the highest light demands, highest alkalinity, calcium demands, and they're just not as tolerant to dirty or poor water conditions. They need the tanks to be absolutely stable to thrive the best. This purple stylo is generally one of the beginner SPS corals that we like to push here at the store, just because it's kind of one of the least picky of the SPS family, but it is just as beautiful as any other. Typically with the SPS, you get some of these branching growth patterns like the stylo here, where it grows out jagged, branched, kind of just like a tree, whereas we have a couple different growth forms with these two, whereas we might get plating corals or encrusting corals that grow off of the rockwork or tight to it.
Thank you, Eli. So that's a small taste of our upcoming series, What is a Coral? Join me and Eli whenever we can find the time, and I'll be trying to take you towards a little bit more of the wild coral reefs and a little bit of a context of what's going on over there, and then join Eli in the trenches where we take what we've learned in the wild and we take what technology and experience we have in the aquarium trade. We learn to not only have success keeping corals alive in captivity, we find new sustainable ways to produce them, we find new ways to make new, novel, beautiful aquascapes that have never ever been seen before. So, like always, please subscribe, please share with anyone who's interested in aquariums or trying to get into the coral trade. If you're looking for supplies because no coral tank appears in a vacuum, feel free to visit our website, www.osachoice.com, to shop for all the supplies you'll need to have a successful coral tank, and feel free to come to any of our locations, Coventry, Wakefield, or Seekonk, to ask away anything you might have, any concerns with flow, water chemistry, light. That's why we're here. So, from me, Eli, and the rest of the OSA gang, keep reefing.